In the 19th century, Carl Friedrich Gauss, Nikolai Lobachevsky, and Janos Bolai refuted the fifth axiom of Euclid. The refutation was not simply an abstract concept which created great mathematical advancements, but it was a refutation of our fundamental understanding of the science of nature. This was the cornerstone of the infinite parallel line concept and the universe being curved.
Let's look a little more carefully at what it means to believe the Euclidean geometry is necessarily true. How could such a claim be proved? Well, there have to be some initial assumptions in order to get started. This is just what Euclid's 5 postulates are, statements we can't imagine being without. And then we'd want to reason from them to the rest of our beliefs about physical space. In that way, we would have shown that those beliefs are necessarily true.
To draw a straight line from any point to any point. To produce a finite straight line continuously in a straight line. To produce a circle with any center, that's a point, and any distance or radius. All right angles are equal to one another.
No one doubted that a line could be drawn between 2 points, or that a circle could be drawn. But the 5th postulate wasn't quite so obvious.
If, in a plane, a third line crosses 2 others, and if the sum of the angles alpha and beta is less than 2 right angles, then the lines will eventually meet.
That is to say, they discarded the postulate and tried to deduce it using just the remaining assumptions of Euclid. They make a sensible place from which to start.
People really there was this very easy opportunity to discover non-Euclidean geometry years and years before, and it somehow had been ignored. People got sidetracked by Euclid's 5 postulates. Instead of just asking, what's the natural thing to do? What should we really be doing here? It's hard for us to imagine how important Euclid was to these people. It was like a Bible. It really was like a religious text. There is another non-Euclidean geometry. In fact, arguably, it's the most important geometry historically. What's that? That's the geometry of a sphere.
On the surface of this sphere, we can imagine the straight lines as being great circles. Now let's consider a straight line parallel to this one, but through this point on the equator. The angles at these 2 points on the equator add up to 180 degrees. But as I move up the globe, the lines get closer and closer together and eventually meet at the pole. And whatever line I draw through this point, it must eventually meet this one somewhere. So there are no parallel lines here.
This notion of parallelism turns out to be the key in kind of unlocking new and mysterious worlds. In 1820, 1830, independently, two mathematicians, a Hungarian, Bolai, and a Russian, Lobachevsky, they independently discovered what we now call hyperbolic geometry. And the fifth axiom, so we can write maybe 5 prime, can be stated like this. Given any line and a point not on that line, there exists infinitely many straight lines through that point parallel to the given line. So this new world is the hyperbolic plane which they've created. Well, I actually said, out of nothing, I have created an entire world.
His second geometry was one in which there are many straight lines through P that never meet this line.
All that I can say now is that I have created a new and different world out of nothing. All that I have sent you thus far is like a house of cards compared to a tower.
And because their geometry turns out to be somewhat different from that of Euclid's, we have to suspend many of our conceptions of the world and prepare to enter a new universe.
If you draw a triangle on a flat surface, you will have an empirical experience of straight segments and angles that sums up to 180 degrees. If you make a homotopy of that triangle, you will still have an empirical experience of straight segments and angles that sums up to 180 degrees. But what if you make a homotopy the size of a continent? What shape will the triangle have? General relativity dictates that everything is curved in the universe, so you cannot possibly have a Euclidean structure that defies the curvature of the Earth. Therefore, the homotopy the size of the continent will inevitably have round segments that follows the curvature of the Earth.
And on this surface, the angle sum of any triangle is 180 degrees. So this three-dimensional atlas confirms that a three-dimensional non-Euclidean space is possible. It now does become a matter for the experimenter to determine which geometry is the true one.
That also means that the initial triangle also has round segments.
And in fact, this kind of geometry had been studied for millennia. Ptolemy had studied this. All the astronomers were more interested in spherical geometry than they were in planar geometry because, as I've mentioned many times, the night sky is obviously a sphere. What goes on in the night sky is really happening in the celestial sphere, and so it's obvious that the sphere was important.
Now here's the magical question. If the geometry of a spherical universe was so obvious in the first place, at what height does the transformation between the Euclidean perspective and curvature happens? This is what we could call the limit of the empirical perspective, because on one hand, you have all humanity that is stuck in the Euclidean perspective, and on the other hand, you will have the space magic. And this limit, in regard to many topics of science, has always been patched with proof by images. This is where you need pictures up above, where you get to see the curve.
Just almost impossible to articulate what it feels like. That is the real shape of the good Earth.
But in reality, the real empirical proof that we have of this epistemological refutation is the 24 astronauts that either landed on the moon or went in orbit around the moon more than 100 years later.
So easily does the human mind accept the impossible, a man on the moon.
At one point in history, everyone saw the Earth as a globe from their living room. We have a few elites that claims to have experienced the hyperbolical realm, but the rest of humanity is stuck in the Euclidean perspective. So get this, people believe that they cannot draw straight lines.
On the surface of this sphere, we can imagine the straight lines as being great circles.
Even though that they can do that every day. For me, it's the big irony of an atheist right there. You know, rejecting a God he can't see, resorting on science for the burden of proof, but yet believe he can't draw straight lines. And the empirical proof of that is 24 testimonies. For sure, there is a big logical consistency to all of that. And this is not what I'm tackling at all. What I'm addressing here is the coherency between the premises and the conclusion, the fundamental beliefs.